In section 3.5, we're going to learn about solving quadratic equations by completing the square. It's actually a very useful property. Some people even prefer this over solving with like quadratic formula and stuff like that. That being said, it does have some limitations as far as like some numbers don't always work so well. It can also be useful though in situations where we're trying to get something into a certain format, like vertex format, as you'll see here down the road. So, what are we talking about here? Well, we're looking for things that we can square root. We're going to look for a lot of perfect squares. And we've done some stuff already. Like if I have like x squared minus 49 here, we know that we can use both 7 and -7 as answers. So don't forget about this plus and minus aspect of things. Like here, they're showing you x squared equals 121. If you square root both sides, we're going to square root that 121 to get plus or minus 11. Both positive 11 and negative 11 work here. We may also see some answers that are complex numbers. They'll have a real and an imaginary part, and we'll get into that. Or there might be answers that are irrational, just can't be simplified like this here, which is plus or minus 11. All right, perfect square trinomials, what we're going to be looking for is a whole expression here that we can actually write down into one little simple thing like this that makes it actually easier to solve, as you'll see in just a moment. So for example, x squared minus 8x plus 16 has a special pattern. It's really x minus 4 times another x minus 4. So really we just say that's x minus 4 squared. Or this expression is really x plus 2 times x plus 2, or x plus 2 squared. So we're going to try to get one side of the expression to be something like this here. Then we could square root both sides, and it's pretty easy to solve after that, as you'll see here on these examples. So, well, before I like move 25 or anything like that, what I'm going to just look for is, oh, this here can actually be factored. It's just going to be x minus 2 times another x minus 2, or x minus 2 squared. And just leave the 25 over here. So part of this is kind of recognizing that I can just leave it the way it is. I don't have to move it equal to 0. And we'll talk about that and see the different examples. You can then square root both sides. The square root and the square root cancel, so just leaves x minus 2. When we square root 25, don't forget we get plus and minus 5. And then all I have to do is add the 2 over. Just remember you're going to get two different answers here. 5 plus 2 would give you 7, and -5 plus 2 would give you -3. Feel free to pause and try out these other ones or just follow along with me here. You might see some bigger numbers and you can just square root it because these are going to be a lot of perfect square things here. So if you square root this, you get, I believe in this case, 19. And if you check it, it's really x minus 19 and another x minus 19. -19 and -19 combine to get -38, and they multiply to make 361. And then we can square root both sides. That brings in x minus 19. Feel free to use a calculator on these larger numbers. Square root 576 to get plus or minus 24. Don't forget about that. And then you just got to add your 19 over. And if I add that, 24 plus 19 gives you 43. A -24 plus 19 would give you -5. Don't forget, you can actually take these answers, since they're pretty nice, and plug that back in for x's and make sure they actually work. When I plug in 7 both places, I should get 25. When I plug in -5 in both places, I should be getting 576. So you can always test your answers. Let's see though when we have, not as a pretty of an answer, we're going to have an irrational root. Same process here. So we're going to basically condense this down. We got x plus 12 times x plus 12, or x plus 12 squared. We can square root both sides. Bring down the x plus 12, and then this here is square root of 192. Well, we can't square root 192 perfectly. What we can do is try to break it up. Remember, we talked about different ways of breaking it up. I chose 64 and 3. You can square the 64 to be an 8, and then the 3 just stays inside the square root. Don't forget about your plus and minus. We're still square rooting both sides. I need that plus and minus on it. Actually, it's pretty easy. I just need to minus a 12. Since none of these go together, I'm just going to rewrite it. We like to put the real part first, so -12 plus or minus 8 root 3. If I really need an answer, I would take -12 and add 8 square root of 3 and get some odd decimal answer. Or I would do -12 minus 8 root 3. So you might get some answers that are not so pretty, and in some ways it's even less work. Here we had to actually get the answers. Here I just move the number over and I'm done. Let's try that with a complex solution. That should be our last one for this section here. Notice this one's also unique because you could divide everything by 2. It's not unique to complex solutions. It's just they're thrown at you right now. I can actually go through and divide everything by 2 and just make it smaller. So now I got reduced answers. Still a large number, but if you square root this, it does work out well. It's a perfect square. 23 and 23 can get 46 and multiply to get 529. So I set it up in this factored form here, and I can square root both sides, and now I just got x minus 23. When you square root this, remember we have issues with square rooting negatives, and it's going to involve I, and we can't square root 36, it's just 6, but it's going to be 6i. Again, don't forget your plus and minus, whether it's real or imaginary or complex or whatever. We just need to move the 23 over, and then this would be my final answer. Let's put the real part first, plus or minus the 6i. And there you go.